Okay, so we have another example here. So Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? Okay, so let's see. Um, so let's go ahead and draw our castle first, right? So let's say the castle is floating around. Let's say it's somewhere around here. All right, what does a castle look like? Maybe something like that. Um, it's got those little thingies up at the top. Why not? Maybe there's like a little window for like a princess to be hanging out. Okay. Anyways, that's my castle. And then we have Leah. Let me draw a straight line here for the ground. So then we have Leah right here. A little tall there. Let's go ahead and zoom in just a little bit. We have Leah here, who's about 5.5 feet tall. So she has a height of about 5.5 feet. The castle has a height of 190 feet, correct? 190 feet. So let's grab a different color. So this has a height of 190 feet. Okay. And then it gives us the angle of elevation, right? The angle of elevation is 38 degrees. Now, this is a part where we have to be a little bit careful with this question because the angle of elevation is going to, or the horizontal line is going to start at the top of her head, right? So where she's looking, right? She's looking with her eyes. So from her eyes, this is our horizontal line right here, right? This is our HL, my horizontal line. So the angle of elevation is going to be the angle that I make with that horizontal line and the line of sight to the top of the castle. All right, so it'd be something like that. And then here's my 90-degree angle. So now I get this, I get a triangle, I get this right triangle. Let me try that again. So now I get this right triangle. Okay, so now we've got to kind of figure out what are all the side lengths of this triangle. So we know the angle of elevation is 38 degrees. I know this is 38 degrees. I know that I want to find her distance from the castle. So I want to find what is this distance x, right? From where the castle is to where she is, right? And I also know the height of it. But we got to be careful here because if you notice, the height of the triangle is not equal to the height of the castle. So now you got to think, what is the height of this triangle here if I know the height of the castle and I know the height of Leah? Well, then this has got to be, I have to just subtract them, right? I should have to do 190 feet minus 5 point feet, right? Because I'm trying to get rid of this height of 5.5 feet, right? I'm not including that. I'm taking this piece away. So then that's going to give me 190 minus 5.5 feet, and that's going to give me 184.5 feet. So now that's the height of my triangle here. So 184.5. Now we can go ahead and solve our trig value here, right? We can solve for our trig here. Let me scoot this. Oh no. Let's try that again. I just want to scoot this over. Okay. Let's find our, let's use our trig values then. Now look what we're given. We're given the opposite side, right? This guy is going to be the opposite side. And then this is going to be your adjacent. So again, we're using tangent here, right? Tangent of my angle is equal to the opposite side divided by the adjacent side. So put a 1 under here, we're going to cross multiply, and then we are going to end up with a 1 times 184.5, that's 184.5, equals x times the tangent of 38 degrees. Then I'm going to divide by the tangent of 38 degrees, divide by the tangent of 38 degrees, and just plug that into your calculator. 184.5 divided by the tangent of 38 degrees. And I get x equals 236.149. So she is let me get the distance, feet, right? Feet. All right, the units is going to be important for word problems. All right, 236.149 feet. Okay, example 4. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person to the nearest foot? Okay, so we've got some water. All right, let's draw a picture out. All right, we've got some water. Let's draw it up here. Why not? Got some water up here. Okay. Now it says that search and rescue team is airlifting people from the scene. Right. So there's a helicopter that's 18 feet above the water. So we have a helicopter somewhere above the water. So here's our water. Let's say our helicopter is right around here. Whoops. Okay, this is kind of glitching a little bit, but that's okay. It'll come back. Give it a second. Give it a second. There it goes. Okay. So my helicopter is somewhere around here. There's a tail of it. And then here's like the body of it. I'm not an artist, so... Alright, there's my helicopter. Okay, perfect. Okay, so helicopter is 18 feet above. So from here, from the top of the helicopter to the water is about 18 feet. Okay. The angle of depression to this other person is 42 degrees. So so from the helicopter, you're looking at a person, right? You're looking at a person who's out over here somewhere, right? So let's say this person is, let's say this person's right over here underwater, and they need help. So it says the angle of depression, right? So remember what angle of depression means. It means find your horizontal line. So since it's angle of depression, you're looking from the helicopter. So this is your horizontal line right here. This is your HL, your horizontal line. So the angle of depression is going to be that angle from that line that goes down. This is where most people kind of make mistakes, right? They kind of misplace where they put that angle, right? A lot of times I'll see them put the angle right here, and it should not go there. Right, it goes right where it's at right now. So the angle is 48 degrees. Just wanted to double check that. All right. Now it's asking, the question is, what is the horizontal distance from the rescuers to the person to the nearest foot? All right. So we want to find the horizontal distance. So I want to find what is this value right there. All right, this is my horizontal line. I want that distance. All right, I need to create a right triangle out of this. So I'm going to go ahead and just draw a straight line down, and then there's my right triangle. So I'm looking at this triangle right here. Right, and this kind of and if you notice, this should be just like the triangle we started off with, right? Remember when we went back to angle of elevation depression, right? See how your angle of depression is always kind of upside down? So that's kind of the idea there. All right, so now that we have all of that information, we can go ahead and solve for x, right? I know this opposite side here is going to be 18 feet, just like the opposite side is. If this is 18 feet, this also has to be 18 feet. So I have opposite and I have adjacent, so tangent. Lots of tangents, right? So a lot of times when you're in real life problems, you use tangent almost all the time. So then we've got opposite, and then we've got the adjacent. So 18 divided by x, and then we're going to go ahead and cross multiply this. We've seen it a few times, so I'm not going to show all the work. And then I'm going to go ahead and just divide by the tangent of 48, and that should be our answer. And plug it into my calculator. So I've got 18 divided by the tangent of 48 degrees, and I end up with 16.207. And there we go.